Welcome to the Backoff webinar. My name is Torsten Budde. I'm product manager in the IO department. And today we have the topic from the IO-Link sensor into the cloud. Today with me in the webinar is Sven Goldstein, product manager in the TwinCAT department. So I will start with the IO-Link sensor part, and later on Sven will explain all the details regarding the cloud. Maybe you already know it from other webinars. You have the possibility to ask questions during the webinar. So please use the question window. You see it here on the right side. And we will answer as many questions as possible at the end of the webinar. So let's start with the topic from the IO-Link sensor into the cloud. Here we see all the components that are required to talk to sensors and actors with an IO-Link interface. In the middle here we see an embedded PC. So first of all I would like to start with the components and some basics. IO-Link is a point-to-point connection. What kind of components do we need? We need an IO-Link master, here a terminal in this example, and a so-called IO-Link device. So all the different sensors and actors you can connect to the IO-Link master. And the cable, here it's enough to have an unshielded cable in 3 or 5 wires as a standard cable. And because we are talking to sensors and actors, IO-Link defines itself as a technology to talk to sensors and actors. What kind of IO-Link components do we have in our backup portfolio? We have IO-Link masters in IP20, here we see an EtherCAT terminal, and IO-Link masters in IP67. On the IO-Link device side, we only have IP67 devices, but here we have different form factors and different housings available. In IP20 we have the bus terminal and the EtherCAT terminal. Both have 4 ports, so 4 IO-Link ports to connect 4 different sensors or actors. And in IP67 as class A, I come to the difference between class A and class B later on. We have masters with 4 ports, but we also have masters up to 8 ports. Here in this case it's an EtherCAT box, but we also have an IO-Link master in EtherCAT P. So what are the difference between tape A and tape B, or how they called in the specification class A and class B? Class A, here we have no connection at pin 2 and pin 5. This is not specified in the IO-Link specification, but it's possible, for example, for the manufacturer to add additional digital channels to these pins, but it's not specified. In class B or type B, these ports are specified with an additional power supply for devices that need a higher power requirement. So you can talk to actors, sensors that need more power than the standard ones in class A. And the communication channel is marked with CQ. That's exactly the same in both types. Regarding the cables, so we need the 3-wire cables for type A and the 5-wire cables for type B. The maximum length is 20 meters, that's specified in the IO-Link specification. And of course at Backoff we have IO-Link cables available. On the bottom you see here the part numbers for the different classes. We have also class B masters in IP67. Here as an example, again 4 ports or up to 8 ports with totally different types and different power supplies. So please take a look at our Backoff homepage to see the complete portfolio, because these are only 3 examples. Take a look for details what kind of power supply you need for your sensors. And we also have in IP67 the IO-Link devices. They're called IO-Link boxes. So you have the possibility to add these IO-Link boxes to one IO-Link port and then split up these one IO-Link port to up to 8 or 16 standard signals. So you can connect 16 standard sensors or actors, for example, as a digital output or digital input sensor or actor, or an analog input or output. That's also possible in the portfolio, and in different form factors and different housings. Here you see one on the right side in metal. Let's take a look at the IO-Link topology. We have the IO-Link devices on the lower level, or standard sensors connected via the IO-Link boxes to the IO-Link master. Then via fieldbus we're connecting the different IO-Link masters, and then they're communicating to a PLC, and then maybe via Ethernet to different PCs or different components. And at backoff we mainly use EtherCAT as our standard fieldbus to talk between the different IO-Link masters to the PLC. So we have the IO-Link devices, we have the masters. What else do we need? We need an engineering tool. Set up all the different parameters of the IO-Link devices. And the advantage is that the engineering tool is directly integrated in our software TwinCAT. So you don't need an additional software to set up all these parameters. Let's take a look in TwinCAT. Let's do a scan. I have two IO-Link sensors connected and two IO-Link boxes from backoff. This may take a while because the embedded PC is not directly here on my desk. It's on a rack somewhere else. So we're now connecting via the internet to the embedded PC. So now we found 4 devices. Okay. Would you like to scan for boxes as well? Yes. And now we found a IO-Link EtherCAT master with 4 ports. And of course I would like to scan the ports as well. And now we found out that some description files for IO-Link are not already on the local PC. So I'm scanning here as well and download the files and activate the free run. And that's it. So I don't know if you have stopped the time, but it took around 1 minute to do a complete scan to set up the complete IO-Link topology. And if an IODD file is not already on the local PC, then TwinCAT connects automatically to the IODD portal, where I think by now there are around about 15,000 different sensors and actors available with IO-Link. So we're doing a directly connection. You don't have to take a look at every single sensor supplier homepage to download the description file. Let's take a look at the terminal in detail. So of course we see here all the scanned ports with the process data of the sensors and the IO-Link boxes. And here we have the IO-Link folder. That's exactly the configuration tool. And here we see the 4 ports. One sensor is from Pebble and Fuchs and one is from SICK. And I see here the catalog on the right side. And instead of scanning, I can do a drag and drop to the different ports. It's also possible if I have the sensor in the catalog, or if the IODD is not available on the local PC, then I can click here on the IODD finder. I'm now typing in the SICK sensor WTB4C, and here we have the different ones in the list. And if I place the mouse on the picture, then I see that one IODD is on the local PC, the others not, and if I do a double click, then this one is downloaded as well directly from the IODD portal here in TwinCAT. So if I now close and take a look at the catalog, then I see that now both are available from SIG, the one I connected and the other one where I only downloaded the IODD file. What else can I do? What kind of information do I have? Of course, I have the parameters of the sensor. Here we have the list. I can click the read button and read out all the parameters from the sensor. And now I get a feedback with the green arrow. Everything is read out. And if I do a change, for example, here the input filter, I will change the input filter from 3 milliseconds to 10. Then we see the change of the symbol, that something changed. But this is not written down to the sensor. Then I have to click the right button and then I get the response. New filter is written down from the master to the sensor. Then I have another possibility to store the information into the parameter server. If I click the store, then you see a change of the symbol again. Then it's also stored in the parameter server. This parameter server is implemented directly on the terminal in the IO-Link master in this case. If I would like to take a look at the information stored in the parameter server, right click and then to parameter server, here we are. Here I see all the different information if I press read. These are the information stored in the parameter server. So if I change a sensor, then I don't have to do the complete parameter setup again. This will automatically download from the master to the sensor from the parameter server. I can take a look at the process data, of course. Here we have a graphical view of the process data. So it's very nice to see in this graphical view all the different bits and bytes of the sensors, of the IO-Link sensors. So a nice possibility to take a look at the process data in detail. We'll close this window. Especially for series production, it's very useful, so I can copy a complete port. So I just have to set up the parameters for one sensor and then I can copy the parameters from one port to another. So I can copy the sensor at port 1 to port 2 and port 3 and port 4 in this example. Just with the copy paste function. Yes, I would like to override it. I can do the copy paste over different masters, so from one master to another, not only in one master between the different ports. So this is also a very nice function, especially if you produce in higher volumes, that you don't have to set up every single IO-Link sensors again and again if it's exactly the same over the complete machine. So these are some functions and some details as an example of the IO-Link configuration tool directly in TwinCAT. And now I would like to switch over from TwinCAT again to the PowerPoint and would like to hand over to Sven.
Thank you very much, Torsten. As we have learned today, we have a lot of functionalities within our automation software to acquire sensor data. Whether it is IO-Link, EtherCAT, Profibus, Profinet, all of the different field buses out there, we support in our TwinCAT automation software. Since 2015, we have a product family inside of TwinCAT, which is called TwinCAT IoT, and this product family allows to establish cloud connectivity between a machine controller and a cloud service. It can be a public cloud service coming from a cloud provider like Microsoft Azure, Amazon Web Services, IBM, Watson, or Google. But it can also be a private cloud that customers have established on their own, which is only available within their own machine network. And TwinCAT IoT offers the connectivity products that allow you to connect your IoT devices, your controllers, with each other or with the cloud service. TwinCAT IoT offers different kinds of products, which are based on standardized connectivity protocols like MQTT, HTTPS, or OPC UA. And the first product that we have there is our IoT communication product. It's basically a set of function blocks available for the PLC that allow to establish MQTT connectivity, so publisher-subscriber connectivity between the PLC and an MQTT message broker. The IoT communication product also allows to secure the transport channel between the PLC and the message broker, and it uses TLS for that. So client-server authentication, data encryption on the wire, different kinds of functionalities which are available there. And you can pretty much define the data format that you would like to use your own. So we do not force you to use a specific data format. Of course, we support standardized data formats like OPC UA JSON, to our own TwinCAT JSON data format, but you can also create your custom JSON format or XML maybe, or you can also send binary data streams via MQTT. The next product that we have in line here is our so-called IoT data agent, and it is a gateway application where you can define and design the data flow using a graphical configuration tool. So you see that here as a screenshot. You can define the devices from which you want to grab data, and then you can define where the data should go. So whether it should go to an MQTT message broker in your private cloud, or whether it should go to Microsoft Azure IoT Hub or AWS IoT Core. So there are different connectivity modules inside of this IoT data agent. The IoT data agent also has an OPC UA client integrated, so that you can also connect to third-party devices, to third-party OPC UA servers. So if you have, for example, an S7 1500 in your network, you can use the IoT data agent to connect to that controller and read or write data to that OPC UA server. The IoT data agent, as I said, it's a gateway application which is typically installed on an edge PC, on an edge device in front of your machine controller. So you can also use it in a retrofit scenario if you want to enhance your existing machine controller with cloud connectivity, for example. We also have a product which is called the IoT Functions, and this product allows to connect or to use the data flow network that you have designed in your IoT data agent, so that you can also use it from inside of the PLC. So basically it's a set of PLC function blocks for the IoT data agent. So the configuration that you have created there can then be used and triggered from inside of the PLC context as well. We also have a smartphone application, the IoT Communicator. It's available for Android and iOS, and it basically, like I said, it's a smartphone app which also integrates push functionalities. You can read data from the PLC, you can write data to the PLC, and everything coming from a native smartphone application. A relatively new product that we've had since the beginning of this year is our HTTP client for the PLC. So it's a function block for the PLC that you can use to connect to a REST API, so to a web server that offers a REST API, and HTTP is offered as is used as a transport. And then you can trigger HTTP commands like get, post, put, using function blocks for the PLC, and you can also, of course, secure the transport channel using TLS, which is then called HTTPS. You all know that from browsing the internet, and so you can use HTTP client connectivity inside of the PLC. This product is very interesting because it offers and it allows to connect to cloud services that offer a very different variety of functionalities. So it can be weather forecast, it can be maybe the Telegram messenger that I will also show you later. It can also be, I don't know, an Amazon S3 bucket, or you can launch virtual machines on the Amazon cloud or whatever. So really very different functionalities and cloud services that you can connect to using this product. The next IoT product that we have is our EK9160, the so-called IoT coupler. It's an, let's say, IoT-enabled hardware which integrates an OPC UA server and an MQTT client. So you can use the MQTT client, which is, by the way, also certified for the Microsoft Azure IoT Hub and also is an AWS qualified device. And you can use the MQTT client to connect to message broker in order to send the telemetry data coming in via the I/O channels to that message broker. If you say, well, MQTT, that's really nice, but I don't want to use cloud connectivity, but I want to have a very easy and standardized way to access the I/O data, then you can make use of the OPC UA server that's integrated into that device. So it's really like a plug-and-play configuration. So you simply attach the I/O terminals to the device, you boot the device up, and all the I/O channels are immediately available via the OPC UA server. So you can connect your OPC UA client to the server and immediately see your sensor data. So that's really nice and convenient, and it really reduces your engineering time. Because you don't have to worry about and mess around with okay, what setting do I need here, which setting do I need there, do I need to set this checkbox or that checkbox. So that's not required. Of course you can do so. There's an integrated website that allows to configure the device, but from the beginning everything is plug and play. So just put in the terminals, boot the device up, and then you're ready to go. So let's take a look at the different IoT scenarios that we can solve, or that our customers can solve using our products. Of course, I already said that we support all the different major cloud service providers out there, like Microsoft Azure, Amazon Web Services, IBM Watson, Google. But we also, of course, because we have focused on providing standardized connectivity using standardized transport channels, we support way more cloud service providers that you see here on this slide. But those are only the most prominent ones. So if we take a look at the left-hand side of this slide, we see that, of course, and everyone will believe us, that we, with our latest automation software, TwinCAT 3, of course, we allow our customers to establish MQTT, HTTPS, or OPC UA connectivity with the cloud. But using our IoT data agent, we also support to connect to legacy applications, let's say a 15-year-old machine that's been running out there, but now you want to enhance it with cloud connectivity because maybe you want to send data to the cloud in order to analyze it or display it on a website or something. And then you can use an edge device to run this IoT data agent on there, connect to your existing machine controller or to a third-party controller, and then grab the data and send it out there. So if we go further down to the field level, we saw that we also have this EK9160 IoT coupler, which offers a plug-and-play configuration for MQTT and OPC UA. And we also give our customers the answer to the question, what can we do with the data after we have sent it away via MQTT? Are there any backup tools available to analyze the data? And the answer is yes. So we have an own analytics software package, which is called TwinCAT Analytics, that lets you access the data or subscribe to the data using MQTT in order to analyze it using advanced analytics algorithms. So, but if we say, well, this is all nice, but maybe I want to shovel all the data out of the regular back-off tool chain. Maybe I want to use third-party tools, because connectivity is also about third-party connectivity, right? So what kind of options do I have there? So I brought 3 examples. The first one is Microsoft Power BI. Power BI is first of all, they started with a desktop application, but it's also available as a web application on the Azure cloud. And it's an application where you can visually analyze data coming from different data sources, for example, a database. And what you can do, and you see that here on the right-hand side as a little architecture drawing, you can send data, of course, from our controller to via MQTT to the Microsoft Azure IoT Hub, which is like a message broker on the Azure cloud. Then you can set up a stream analytics job that forwards the incoming data from the controller to an SQL Azure database. And from there, you can subscribe your Power BI application to the database to grab the data and analyze the data visually using this Power BI workbench here. Another example, and it's coming more from the open source world, is Grafana. So Grafana is an HTML5 web-based dashboard which you can design and configure. And the setup from an architecture point of view is very similar. So we send the data via MQTT to a message broker. Then maybe you have a Node-RED network that's picking the data up and is forwarding the data to a database. In this case, I used InfluxDB, a time series database. And then from this database, the Grafana application can pick up the data and display it on an HTML5 web page. The third example, and like I said earlier, there are many ways to solve different connectivity use cases, and the three examples here are really only examples, right? It's not like a cookbook where I say, hey, this is the recommended way of doing things, but it really depends on your application project. And this is just, like I said, an example how you could solve a potential use case in your scenario. So the third example I brought is SMS and email notifications. So you often want to send notifications from your machine controller, maybe to the machine operator, in order to notify him of a mail function maybe, or just a status information of your machine. And what you typically did in the past was, in the case of SMS notifications, you used a separate modem hardware, right? Where you put in a SIM card in order to have access to the wireless broadband connector maybe. So, but what you can also do in the modern world is just make use of the regular internet connection that you maybe have on your machine. So in that case, there are many cloud providers that offer notification services. For example, Amazon Web Services, they have a service which is called Amazon SNS, Simple Notification Services. And you can make use of that service by sending out an MQTT message from the controller to the message broker on AWS, which is called AWS IoT Core. And from there, you have a rule chain that you can configure to forward the data to Amazon SNS. And there you can say, okay, now send out an email or send out an SMS. Maybe it depends on a tag that you set inside of your PSC context, right? Where the PSC says, okay, I want, because this is a really high importance alarm that has to be sent out, so it shouldn't be sent out via email. Maybe it should be sent out via SMS so that the machine operator immediately sees what's going on and sees that on his smartphone. So that's a way of doing that. Like I said earlier, you can also use our HTTP client inside of TwinCAT IoT to maybe talk to a messenger service like Telegram. So Telegram offers an API which is called the bot API, and this API has an HTTP interface, and you can connect to that interface using our HTTP client from inside of your PSC context, and then you can send out messenger texts to this Telegram bot API. So really nice functionality. So coming back to our IoT scenario overview, we have also introduced lately a new cloud service from Beckhoff, which is called TwinCAT Cloud Engineering. And of course, this TwinCAT Cloud Engineering service, which is all about hosting TwinCAT in the cloud, can also connect via MQTT, HTTPS, or OPC UA to all those different cloud service providers to get the data, forward the data, store the data, analyze the data. So whatever you have in mind for your machine project. So TwinCAT Cloud Engineering is basically the functionality that we offer customers so that they can log into a website, to the back of website, and then they have a graphical overview of all the different TwinCAT instances, so which is like a virtual machine instance where TwinCAT is pre-installed. And from there they can use the TwinCAT engineering environment in order to work on their machine projects. Then they have a secure communication channel to physical controller hardware as well, and everything is happening from inside of the web browser. You see that here, the laptop screenshot here shows the dashboard that we have designed so that customers have an overview of all the different instances of TwinCAT Cloud Engineering. They can interact with the instance, for example, connect to it. And by connecting to an instance, I mean that the connection is also tunneled through the web browser. So it's a regular remote desktop connection to the virtual machine, but everything is being tunneled through the web browser, so you don't need to install any additional software or applications or need special hardware so that you can work with a TwinCAT Cloud Engineering instance. So everything that's running inside of the instance is a regular TwinCAT installation, basically. So you have the TwinCAT engineering in there using Visual Studio. You have also a non-deterministic TwinCAT runtime in there. You have the possibility to use our TwinCAT HMI, and of course also a combination of all these different TwinCAT products. So you can, for example, here in this use case, you could use our TwinCAT Analytics on there, on this TwinCAT Cloud Engineering instance, to analyze data coming in via MQTT from all the different machine applications out there. So you could analyze the data using TwinCAT Analytics, but then you can also make use of the advanced TwinCAT Analytics functionalities like the PLC code generation or also the one-click dashboard functionality, where you can automatically generate a TwinCAT HMI visualization based on the analytics network that you have configured. You see that here as an example. So this is a TwinCAT Analytics project that you see here. Everything integrated into Visual Studio, so there's no new programming language that you need to learn, no new tooling. So everything is integrated into the engineering environment that our customers already know from using TwinCAT 3. So you have different algorithms available where you can design your analytics network, and then you can link all the different inputs to the analytics network with data coming in from your machines via MQTT. And out of that, you can automatically create an HMI dashboard using our TwinCAT HMI. You can also customize the dashboard using your own logo or color scheme. And of course, every algorithm on the analytics network has an own control on the HMI visualization, so which is really nice and convenient, and you will have immediately after a few mouse clicks and a few minutes of let's say code generation and HMI generation, you have a full-blown HMI web application available that displays the results of your analytics network. And of course, because everything here in this example is running in a TwinCAT Cloud Engineering instance, everything is also available worldwide on the web, of course only for authenticated users, and everything encrypted on the transport channel. But everything would be available worldwide without any hassles with the network environment or anything. Okay, so that was it from my side. If you have any questions, please make use of the question window. If you have suggestions or proposals for future topics that we should address for you in upcoming webinars, just let us know. Send us an email to gotowebinar@beckhoff.com. And yeah, so otherwise, me and Torsten, we would like to thank you for your attention and have a wonderful day. Thank you.